Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 4 to the power of x minus 2 to the power of x is equal to 1. So now 4 here, I'm going to rewrite as 2 to the power of 2 to the power of x minus 2 to the power of x is equal to 1. So I simply just substitute in 2 to the power of 2 for 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n are interchangeable, meaning this is also equal to a to the power of n times m. And if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we can think of 2 as m and x as n. So now if I switch these two places, I get 2 to the power of x to the power of 2. Now I have minus 2 to the power of x is equal to 1. So now I'm going to subtract both sides by 1. These two cancel out. Now I'm left with 2 to the power of x to the power of 2 minus 2 to the power of x minus 1 is equal to 0. Now I'm going to let y equal 2 to the power of x. So now I have y squared minus y minus 1 is equal to 0. So now to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So now I have negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So now this is equal to 1 plus or minus the square root of 1 plus 4 all over 2 times 1 is 2. And now this is equal to 1 plus or minus the square root of 5 over 2. So now this gives me two solutions. I have 1 plus the square root of 5 over 2, and I have 1 minus the square root of 5 over 2. However, this is the value of y. Remember that we set y equal to the power of x. So now, let's first start with if y is equal to 1 plus the square root of 5 over 2. So we know that y is equal to 2 to the power of x. So if these two are equal to each other, then we have 2 to the power of x is equal to 1 plus the square root of 5 over 2. So now, to solve this, I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 1 plus the square root of 5 over 2. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this can equal b times log a. So in this case, for log 2 to the power of x, I can move x to the front. So this is going to equal x times log 2, which is equal to 1 plus the square root of 5 over 2. It's going to equal log 1 plus the square root of 5 over 2. Now, if I divide both sides by log 2, these two cancel out, and I'm left with x is equal to log 1 plus the square root of 5 over 2 over log 2. So now this is the same thing as log base 2 of 1 plus the square root of 5 over 2. Because if I have something in the form log A over log B, this is simply equal to log base B of A. So this is my solution. Now, remember how there was another solution. If y is equal to 1 minus square root of 5. So if this is true, then I have 2 to the power of x is equal to 1 minus the square root of 5 over 2. However, 1 minus the square root of 5, that's going to be negative. And this means that 2 to the power of x has to equal a negative number. And you can't take the power of a positive number and make it a negative. So, meaning this has no solution. So our only solution is x is equal to log base 2 of 1 plus the square root of 5 over 2. Now, right here, I want to find the value of x. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 3 to the power of x plus 1, this is going to equal 3 to the power of x times 3 to the power of 1. And this is equal to 12. Now 12, I'm going to rewrite as 3 times 4. And now, as you can see, since both sides have 3 in them, I'm going to simply divide both sides by 3. So then these two cancel out and these two cancel out. And now I'm simply left with 3 to the power of x is equal to 4. Now 4 here, this is the same thing as 2 to the power of 2. Now if I take the log on both sides, I have log 3 to the power of x is equal to log 2 to the power of 2. Now if I have something in the form log a to the power of b, it's going to equal, well, I can now move my exponent b to the front. So this is going to equal b times log a. So in this case, log 3 to the power of x, I can move x to the front, and log 2 to the power of 2, I can move 2 to the front. So these are going to equal x times log 3 and 2 times log 2. Now I'm going to go ahead and divide both sides by log 3. So then these two cancel out, and now I'm going to be left with x is equal to 2 times log 2 over log 3. Now, the value for log 2 is equal to 0.301. And log 3, this is equal to 0.4771. So now I have 2 times 0.301 over 0.4771. Now 2 times 0.301, that's going to equal 0.602 over 0.4771, which is equal to 1.26. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 20 minus 11. So, for my solution here, first start with 2 to the power of 20 minus 11. Now, I'm going to rewrite this as 2 to the power of 10 times 2 minus 11, because 20 is equal to 10 times 2. And now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, this is going to equal 2 to the power of 10 to the power of 2 minus 11. Now 2 to the power of 10, this is equal to 1024. So now I have 1024 to the power of 2 minus 11. And 1024, I can rewrite as 1000 plus 24 to the power of 2 minus 11. Now, if I have something in the form a plus b squared, this is simply equal to a squared plus 2ab plus b squared. So in this case, a is equal to 1000 and b is equal to 24. So this is going to equal to 1000 squared plus 2 times 1000 times 24 plus 24 squared. Now 1000 squared, this is simply equal to 1 million plus, I have 2 times 1000, which is equal to 2000, and 24 times 2000, which is equal to 48,000. So I have plus 48,000 plus 24 times 24, which is equal to 576. Now, if I add all of these, well, 1 million plus 48,000 is simply going to equal 1,048,000 plus 576. And 1,048,000 plus 576, this is simply equal to 1,048,576. So this is our answer. However, remember, we have this minus 11. So now I have 1,048,576 minus 11, which is equal to 1,048,565. Sorry, 1,048,565. So this is my actual answer. All right, so I have 3 plus 3 is equal to 5. So we want to prove this statement to be true. So first off, let's say we have 0 equals 0. I'm going to start with this. We have 0 equals 0. Now for my left-hand side, 0, this is the same thing as 9 minus 9, right? Because 9 minus 9, anything minus itself is 0. And for my right-hand side, I'm going to rewrite 0 as 15 minus 15, which is also equal to 0. So I'm not going beyond the rules of mathematics here. This is just simple. This is just going by the rules. So now, 9, this is equal to 3 squared. So if I replace 3 squared with 9, I have 3 squared minus 3 squared. And now 15, this is equal to 5 times 3. So now I have 3 squared minus 3 squared is equal to 5 times 3 minus 5 times 3. And again, this is also going by the rules of mathematics. Now, an important property of algebra is that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And this is a very common property. So as you can see, in this case, for 3 squared minus 3 squared, a is equal to 3, and so is b. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 5 times 3. Now, for my right-hand side here, I'm going to go ahead and factor out 5. So if I factor out 5, I get 5 times 3 minus 3. All I did was I divided 5 times 3. 5 times 3 divided by 5 is 3, and negative 5 times 3 divided by 5 is negative 3. So that's how I got 5 times 3 minus 3. Now, if I divide both sides by 3 minus 3, these two cancel out, and these two cancel out. So now I'll be left with 3 plus 3 is equal to 5. And as you can see, we just proved this to be right. 3 plus 3 equals 5, 3 plus 3 equals 5. So if you're wondering how this is actually wrong, well, it's because this step over here. I divided both sides by 3 minus 3. Well, what is 3 minus 3? 3 minus 3 is simply equal to 0. And if I come over here, I have 3 plus 3 times 3 minus 3, this is 0, is equal to 5 times 3 minus 3 is 0 as well. So now if I divide both sides by 0, well, 0 divided by 0, that's not equal to 1, that's undefined. So you can't actually cancel these two out because these two are undefined. Dividing these two are undefined. So that's where this equation is actually wrong, and 3 plus 3 does not equal 5. All right, so I'm going to prove that negative 1 is equal to 1. So let's first start off with negative 1 is equal to negative 1. This is a true statement because any number is equal to itself, right? So now, negative 1, this is the same thing as negative 1 to the power of 1. Any number to the power of 1 is also equal to itself. So negative 1 to the power of 1, that's also equal to negative 1. And 1, this is the same thing as 2 over 2. So if I replace 1 with 2 over 2, I get negative 1 to the power of 2 over 2 is equal to negative 1. And 2 over 2 again, it's 1, so it's the same thing as negative 1 to the power of 1. Now 2 over 2, this is the same thing as 2 times 1/2. So now if I replace 2 over 2 with 2 times 1/2, I get negative 1 to the power of 2 times 1/2 is equal to negative 1. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So in this case, m is equal to 2 and n is equal to 1/2. So now I have negative 1 to the power of 2 to the power of 1/2. This is equal to negative 1. Now, if I have something in the form a to the power of 1/2, this is the same thing as the square root of a. So this is the same thing as well, first off, negative 1 squared, that's simply equal to 1, right? So now I have the square root of 1 is equal to negative 1. And the square root of 1, that's simply equal to 1. So now I have 1 is equal to negative 1. So I just proved to you guys that 1 is equal to negative 1.